Hello and welcome to this presentation on DirectX11 Transparency. In DirectX, they often use the term blending to talk about creating an alpha, using the alpha channel for transparency. And they talk about blending the current pixel that may have transparency or alpha property with the pixel that's currently in the render target or the back buffer. So there's a few terms that they use, including what's called the blend state. So you have to turn blending or transparency on. There's a blend equation, and there's actually several of these you can use, and they're made up of blend operations and blend factors. You can read about this in the textbook and of course in the documentation, but the most common operation that's used is what they call an additive blending with inverse source alpha. So what this means is that we have a source, which is the current pixel that we're considering, and we have a destination, which is where that pixel is going to be rendered to. In this case, it's our back buffer, our render target. And so it's very common that the factor that's used for the source is to be the alpha channel of the source color. So in this equation, C is the color, F is the blending factor, and the color is actually a 4-channel RGBA color. So what they do is they set the source blending to be the alpha value of the source color, and they set the destination blending factor to be 1 minus that value. So what that means is if the source blending were 50% or 0.5, then the destination factor would also be 0.5, so you would get half and half of each color contributing to the new color that's going to go in the destination of the back buffer. So we can see that if the source alpha is 0, then we would get no contribution from the source, and we would just get a 1 times the destination, which is whatever's already there. So that's completely transparent. And if the source value is 1.0, then we would get a 0 on the destination factor, which means it's completely opaque. We would just get the source color. And so these constants are these blending factors are what's used to control the level of the transparency, and it comes from the alpha value of the source color. So in order to set the blend state, there is actually a DirectX11 blend state descriptor, and we fill that in. And one of the several key parts of this is that we want to set blend enable to true to turn on alpha blending, and then the source blend is source alpha, and the destination is inverse source alpha, and the blending operation is add. So we fill all this in, and we create a blend state, and then we set that blend state for the device context. The question comes up then, where do we get the value of alpha, or the transparency value? And there's several options, and you can probably come up with more. One of these options is that we can get it from the material property. So if an object has a certain material, like when we just discussed in lighting, the ambient, diffuse, and specular material, you could use one of those alpha values as the transparency. Another possibility is you can get it out of the texture map. So certain texture file formats have the capability of having 4-channel colors. PNG is one example. You can actually add a alpha channel to a PNG image to have it transparent. Another possibility is using a color key. So with the color key, you pick out a particular color in the image and say if any pixel is this particular color, then we'll make it transparent. And then also you can pass in to the shader a alpha value that's just some constant, and so you can, in this way, you can make an object hidden and hide and reappear just by changing the alpha value. We'll see an example of this in just a minute. There is an issue with transparency in that a couple of issues in that the order of the alpha, the order of rendering when you render something that's transparent is important. In this image on the bottom, the back buffer or the render target is cleared to a blue color, and the moon here is drawn before the sky billboard. And so the sky billboard is drawn second in this lower image. And what happens is when the moon is drawn, the background is this blue color because the sky hasn't been drawn yet. And so the transparency on the moon is blended with the blue background, not with the sky, because the sky was drawn after the moon. So you can see that this is probably not the effect that you want, and the issue is that the transparent object was drawn before non-transparent objects that are in the background. The upper image probably has the effect that we're looking for, where the background is cleared and then the sky billboard is drawn, and then the transparent moon is drawn, so that the transparent moon pixels get blended with the sky billboard pixels. That's probably the intent that we want. A second issue that can come up is with what we refer to as culling. So if you recall, on the moon, there are polygons on the front side that we can see, and there are also polygons on the back side that we can't see. And if those polygons on the back side are rendered with transparency, it can cause some odd effects. And so we don't want to render back-facing polygons when we're doing transparency. So we make sure that the rasterizer state is set so that back faces are cold. Let's take a look at some code examples. Here is a scene with a background sky image, and so here's our scene with the background sky image and a couple of moons and a pyramid in front. If we wanted to add texture, if we wanted to add transparency, one way of doing that is to add a transparent texture map. And this particular texture map right here is like a chainmail type thing, but the spaces in between are transparent. It may not be easy to tell here in this view, but they're transparent. So if we go to the code and change the texture that's applied to the pyramid, you can see that we now have some transparency, so where we can see through the pyramids, the openings in that chain texture. Let me show you an example of what would happen if we accidentally rendered the foreground transparent object first. If we go to the render, and take this pyramid and move it so that it's rendered first before the billboard, we get an odd effect. You see the blue now in between the openings in the chain. The reason for this is because this is rendered first. At the time the pyramid is rendered, the sky and the moon don't exist, and all that exists in the back buffer is this blue background. So that's what you're seeing in the opening of the chain. So it's important to render transparent objects in the foreground last to get the effect that you were looking for. The next thing that we'll look at is how we can render something with a user-controlled or an application-controlled transparency value. So in the shader, nothing's really done here for the texture. The transparency is taken out of the texture value and just used as long as the blend state is set up properly. Another possibility is that as part of the constant data or some other input, the user can select, or the application can control, just a variable that sets the alpha value. And so what I've got here is an if test in the pixel shader that says if the alpha value is greater than 0, then set the color to that alpha value. So if the alpha value is negative, then we won't do anything with it. But if the alpha value is greater than 0, then we'll actually use it. So what I've done then is in the constant data, I've created in the poly object a variable, an alpha variable for each one. And by default, I've set it to 1. And that means it's going to be completely opaque. There's going to be no transparency. In the setup of the objects, the billboard, I don't want it to use any alpha, so I set it to -1. The pyramid, I want to get its alpha value from the texture map, so I set it to -1. The others, the two spheres, their alpha value will be 1, so they're also going to be opaque. In the update, then, I've added a keyboard control to change the alpha value of the second sphere. So if the user presses the A key, then the alpha value will decrease by 0.4 every second, and if we hit Control A, the alpha value will increase by 0.4 every second. So it'll take roughly 2 seconds to go completely transparent or become completely opaque. And I've set this alpha value inside of a clamp function, and the clamp function just says maintain whatever we get as part of this calculation, make sure that it stays within the range of 0 to 1. That's what we want for our alpha value. So when we run this and look at the second sphere, which is this moon on the left, we can hit the A key and it will disappear. And then we can hit Control A and it will come back, and you can see it in that same effect in wireframe as well. So you can actually control the alpha in code in your application if you wanted some effect like that. Another possibility is to use some type of color key. So in the shader program, this may not be the best way to do this, but what I've done is I've set any color that has a red, green, and blue component above 0.7, make it really transparent, almost completely transparent. So anything red, green, or blue above 7 is going to be something close to white. So if I go back to the texture that's on the pyramid, and change it to be that, I know that penguin guy has a bright white color in it. Then what happens is everywhere where there was a white color in the penguin, we can see through it. And you can also see through the clouds in the billboard. Everywhere the clouds get bright enough above 0.7, 0.7, 0.7, anywhere where they get enough intensity of white, you can see through them as well. So this is an example of using not just color key, not just a single color, but a range of color values to control transparency. So there's a lot of different options that you have. You can get transparency from a vertex color, you can get it from a material, you can get it from a texture, and you can actually get it from a variable, or in the case of the color key example we saw, we can get it from some if test or some calculation. So I hope this helps you to add some interesting alpha and transparency to your projects, and let me know if you have any questions.